So who's heard of Depop? Good answer. Right, so I'm going to talk to you a bit about our sort of inter-regional transit network that we built using BGP, Cisco Cloud Services Router, Terraform, and Packer. So Depop is a social marketplace. Whoop, sorry, should have rehearsed this really. There we go. Almost there. Right, yeah, so Depop is a social marketplace. It has a kind of curated magazine feel to it. And we have a large sort of range of products on sale. It's largely focused on vintage and streetwear fashion, which, as you can see, I'm a keen proponent of. We've been around a little while. We launched in Italy, soft launched in 2012. We kind of publicly launched in London summer 2013. We have 4 offices with engineering located in London. Just to give you some ideas of the scale that we are, these are some numbers. We have 7 million users, 60 million product listed. We serve 400 terabytes of images a month. We have around 30 microservices plus a kind of large monolith, which we're kind of slowly breaking down into smaller services. We don't have huge scale, but we're starting to get to the point at which we have scaling issues and we can't fit things in a single database. We have to start sharding things. Probably next year we're going to start looking at this stuff. This is some of the tech that we work with. We have Python and Django, that's the old stuff. We're starting to break things down using Scala, Play, and Akka. And some of the services are quite small. They're not quite microservices, but they're small. So I started at Depop about 16 months ago. Let me take you back in time to Depop of yore. So we had a relatively simple AWS architecture. Deployments are done using Jenkins pipelines, leaning on Ansible, Packer, Consul. We had immutable EC2 deployments. It's nice and simple. I think it was a decent MVP. Apart from the kind of the pointy clicky that inevitably happened within these accounts. Can anyone spot the problem here? No? Yes, correct. So in order to fix this problem, we have an SSH config file we copy around and we put on a wiki page. When we add a new subnet, we say, can you update so you can actually reach the subnets? We use kind of non-overlapping /24s on the 2 different kind of networks. It gives us the illusion of being able to SSH directly to RFC 1918 networks over the public internet, which doesn't help already confused developers. But kind of DNS was invented to solve that problem. They shouldn't need to know about how addressing works. And this kind of worked. As long as we didn't want to kind of scale beyond a certain size, it was fine. It did the job okay. Apart from if we wanted to do a thing that didn't really work with this pattern, a thing that didn't fit into production, didn't fit into staging, yeah, we can't do this. We can't join the 2 things. They can't route because they're on the same network address space. I can't really do this either. I can't add a new VPC and put some new things over there. I can join one of the 2 things up there, but not 2 at the same time. I can do split horizon DNS and proxying and NAT and some horrific things like that, but I'd rather not, to be fair. So we ended up redeploying the entire thing, which is a really good exercise in tackling the technical debt that had built up in our CloudFormation templates and Ansible playbooks. We did this over the course of a couple of weeks worth of prep and then one very long evening. The next day we had a brand new VPC and it was all good. We can do whatever we want at this stage. We can then kind of get on and build like the next stage of Depop. So just to give a bit of background about myself and why the original layout was such an affront to me, I thought I'd tell you about my home network. I kind of like networks. I used to be a network engineer many years ago. Then I got into development. but I always kept kind of networking with me. I've always had a love for it. And to be honest, like this design is largely a relic of when I had free time. It's not necessarily the case anymore. You might be thinking I live in a large house with many people. No. Why do we do these things? Why do we kind of segment networks? Why do we kind of break them apart? Why do we try and control them? So case in point, this is Egg. He was a very cute and innocent kitten. He matured into a very naughty cat. He sells catnip on the private dark web site in order to fund his own habit. I told him there was no way I was going to let that traffic anywhere near my network. So we came to an agreement, and he now has his own network. So I give him a dedicated public IP address through which he can egress the network, and through which network traffic from the internet can come into his network. I can segregate the two things as he can't get into mine and I can't get into his. I also have plausible deniability if the police come knocking. So back to the original story. We wanted to build the next phase of Depop. We wanted something that was going to scale to the next sort of 7 million, 70 million users, however big we get. So we wanted to kind of plan for something that was going to scale for the long term, something that kind of took on security, something that has security baked in, and something that didn't have any pointy-clicky. Everything should be deployed as code. So we had to think, and we came up with something along the lines of this. This is not empty at the moment, by the way, but we're getting there. Something like 7 AWS accounts and a migration plan to eventually enter the old parent account. And so with a plan in place, we started to build it. As we started to build the thing, we realized we wanted a bit more granularity around specific AWS services, things that don't really fit into the concept of an environment, but things that are important nonetheless. So we have a dedicated account for authentication. All authentication for AWS services comes in via this dedicated account. We use IAM roles everywhere else. We are going to roll out SAML federation at some point. When that comes in, that's going to be terminated within this authentication account. We have CloudTrail. If you're not using CloudTrail, please have a look at it. It's amazing. We've found so many issues in our kind of infrastructure that have just by having access to these logs, it's got us out of jail a few times. So we have a dedicated account to which we forward all our logs, and they get stored in S3 and encrypted with KMS. And we have a Lambda function to then kind of push these logs out to our kind of log entries system. Operations. We did an account to actually manage the rest of the infrastructure, the thing that deploys the thing. So we have Concourse in there, and we have that kind of running Terraform and a bunch of other things, and that's all nice and contained, and it works very nicely. We also have sandbox accounts per developer or per platform engineer. We found that working on these systems when you're actually developing it, you can often tread on each other's toes. You need something that's isolated that you can break on your own. I need to treat kind of staging and production as production, essentially. We then have our kind of environment-specific accounts. So we have development, staging, and production. And then we have 2 accounts within those environments. So we have a front-end account, which is where Depop actually runs, and then a back-end account, which is where things like Console and Vault run. We actually found so far that the development environment is probably overkill. We're probably going to decommission that at some point. Staging is enough for us. We generally prefer that developers work locally using a tool we wrote called Mini Depop, which is essentially the entirety of Depop running within Docker containers on a laptop. Eventually, we want to be able to get to the point where we can run up kind of arbitrary pull request-based environments for things like QA and mobile development. Kubernetes is probably the right tool for that, and that's conveniently on our roadmap, but we're not there yet. So how do we make all these things talk together? We have something like 12 VPCs, something in the region of that. So VPC Peering, it's out of the box. It's supported by AWS. You get decent bandwidth between two peered VPCs. You don't get full bisection bandwidth. If you need large amounts of bandwidth, it's probably best to keep them within the same VPC in the same AZ. Definitely use peering for application traffic between VPCs. Don't do anything like this. Security groups are a wonderful thing. They give you fine-grained access control that is abstracted from the network layer. Terraform support as well. Just having this thing supported out of the box, you can just write some code and suddenly your two VPCs appeared. That's a wonderful thing. This works very well if you're within one region or if you're entirely within AWS, but it kind of breaks down beyond this. No support for multi-region, no support for anything other than VPCs. If I want to have a thing running on GCE, if I want to have a thing running in my own data center, that doesn't work. I can't use VPC peering for that. I need something else. So we have so for one thing, we wanted a remote access VPN server so users could dial in. And if you allocate them an IP address from a subnet that's associated with a loopback interface, that will work within a VPC, but that won't work beyond the VPC to the VPCs that VPC is peered from. I'm then back to kind of needing proxy servers, NAT, Bastion hosts, and this guy again. Faced with that kind of reality, we looked for something else. BGP. Being a networking guy, I love this protocol. It's got many warts, but it's an excellent thing. It comes in two flavors. So you have iBGP and eBGP. iBGP is formed between neighbors in the same AS, and eBGP is formed between neighbors in different AS. For the purposes of this talk, you don't need to worry about iBGP at all. eBGP is much simpler. So BGP is a path vector protocol. So it only cares about the number of hops that it has to go to reach a given AS. It doesn't care about the bandwidth of those links or anything like that. If you have multiple routers between the sites, you can use AS path prepending to influence the routing decisions back to you to kind of inject artificial hops. If we want to influence our outbound routing decisions, we can use local preference, which is to say which links we prefer on the outbound routes. Summary routes is a thing we lean on heavily. Where we have kind of VPC peering in between two VPCs, the routes that shared are generally the prefix for that VPC. If you configure a VPC connection using a kind of a real VPN connection, you tend to have routes for each of the subnets. And because those are smaller prefixes, those are preferred over your VPC peering connection. So you end up with a bunch of traffic coming over the thing you didn't want traffic to be sort of running over. So we just advertise a single route for the entirety of the region that we're in. So the plan was to start building this within Terraform. We wanted immutable deployments of routers. We didn't want to be kind of manually configuring anything. So we wanted Terraform to kind of create all the AWS resources, the customer gateway, the VPN connection, the VPN gateway, and then use the outputs of that to generate kind of snippets of iOS configuration. All these snippets end up stored in the remote state of the VPC side accounts, and the router modules can then access the remote states of those accounts to build a full configuration by kind of concatenating them together and removing the duplicates. We can then use that file to use as a Packer kind of input. So we can then have like an immutable build of our router. This was a thing that I was not particularly enamored with. It felt like I was kind of forcing Terraform down a route that it didn't want to go. There's definitely, when you're kind of dealing with business logic and data, Terraform isn't really very good at separating the two things. I feel like we kind of reached the edge of what Terraform is good at on this project. This is an example of kind of where we reached the edge. So we have a template file here, which is the SSH configuration for a router. Cisco requires that SSH keys are truncated at 72 characters with a new line. And then Terraform has no way of kind of dealing with this data, like it's a string, and there's no interpolation function that will allow you to do anything with it. So you have to write your own module to do it. This is where we found the external data sources to be really useful. They're quite hacky, I felt, but they're excellent kind of get out of jail free cards. You can shell out to an arbitrary program, feed it JSON on standard in, and expect JSON on standard out. And the arbitrary program is essentially this. It's kind of ugly, but it works. So we have a bunch of these things within our infrastructure. We got to the end of this project, well, almost to the end, and we found that the network addresses that we needed were not actually exposed by the Terraform providers. So we thought that we'd come this far and it was all lost. So we ended up having to kind of open up a PR against Terraform, and it turned out to be surprisingly easy. It took about an hour to do, and it was merged in about a day later. Quick demo. I am going to do a live demo here. I'm not. So I'm going to do a kind of connectivity test between the engineering network in London, which has a VPN connection into the transit VPC, which then has a connection to the pair of routers, and then comes into our production VPC, and then to our production console load balancer. What I'm going to do next is turn off the primary router. So as you can see by the date in the bottom corner, this is a live demo to my past self. Cool. So I'm running a kind of a constant ping here back to the console interface. I'm now stopping the EC2 instance that is the primary router. And you can see almost immediately the pings have dropped. This tends to take about 30 seconds to fail over. I feel anxious here, even though I know what's going to happen. Had I had longer, I would have kind of powered up the primary router back again and then done the same on the second. I found these Cisco Cloud Services routers take about 3 minutes to boot, so it's not really kind of suitable for this demo. Eventually, we will see the routes fail over and pings start again, and the primary router is now fully down, and I can now kind of start it again. That's about it.